Hello everyone, my name is Claude. I've been a software engineer at Google for about 5 years. I started off working on Chrome operating system, later search, and about a couple of months ago I joined the Apache Beam team working on the Python SDK and trying to make ML use cases easier. Okay, let me see. Okay, so today I'm going to be introducing the Apache Beam RAG module. We'll start off with an overview of embeddings, vector search, and just the components that make up RAG for those not familiar. I'll discuss the motivation of a specific RAG module in Apache Beam. We'll dive into the components, chunking, ingestion, vector search, and then I'll discuss some brief use cases. So firstly, what are embeddings? They're a mathematical representation of the meaning of some sort of data. Embedding models take the data and turn them into vectors with hundreds of dimensions. This can be text or images. And a key characteristic is that similar vectors or similar concepts cluster together in vector space. So here's an example: puppy and dog might cluster together. So given the characteristic how these similar concepts cluster together, we can calculate the similarity of concepts using either Euclidean distance between vectors or the cosine of the angle between two vectors. And this gives us the ability to search a large corpus of embedded documents to find semantically similar data. Here's an example. If we were to use Euclidean distance on this fake data and our query is dog, we might see that it's exactly the same as the dog. It's very closely related to puppy and not so much automobile. Okay, so given the limits of embedding models, and sometimes our documents are too large to be fit into the token limits of these models, there's often a need for chunking our original documents into smaller embeddable pieces. So some common chunking strategies are just naively splitting the original document into fixed size chunks, or some more advanced like semantically splitting on natural sentence boundaries. Here's a little illustration of what fixed size chunking might look like, and semantic chunking maintaining the paragraph structure. Okay, so RAG. Why do we use RAG? We all know the limitations of LLMs. Sometimes they hallucinate details. They're not necessarily trained on proprietary data or new fresh data that the model wasn't trained on. So RAG combines the ability of vector search to augment the knowledge of an LLM in the prompt so it can give us grounded, up-to-date responses. So in a typical RAG system, is made up of an ingestion pipeline. So you read your data from some source. These can be documents in the case of text. You can optionally chunk your documents if they're too large to be embedded individually. And then we pass these documents to some embedding model, and finally we write these embeddings along with any metadata about the embeddings to a vector database. The other part of a RAG system is retrieval and generation. So here a user might come with a prompt, and we need to embed their prompt so we can actually look up semantically related information in our vector database. So once we have embedded their prompt, we can perform vector search and return relevant data to give along with their prompt to the LLM. So a use case here might be a financial services company that ingests quarterly earnings results of publicly traded companies, and the user might be asking, what was the latest earnings per share of NVIDIA? And in such a system, the vector database will return, hopefully, the part of the earnings release that references the earnings per share, and the LLM can respond accurately and with citation. So why build a RAG module in Apache Beam? Some might be aware that most of these things are already possible, but there are complexities of dealing with embeddings, vector databases, and there is value in abstracting these, especially for users who might not be familiar with Apache Beam. They have a vector database, and they've run into problems scaling embedding generation or enrichment. And the goal of the RAG package is to make all of the abilities of Apache Beam for this use case discoverable, accessible to new users, hopefully extensible by the community, and interchangeable, easily switch between vector databases or embedding models. So as we've discussed, a RAG module should support chunking, embedding generation, ingestion, vector search, and as well as LLM inference. So to make an easily chainable library, I thought about how can we encapsulate the data that flows through an embedding pipeline. And here we define the chunk type. So the chunk describes a unit of data that is to be embedded, along with any metadata about this unit of data, and some other convenient attributes like ID, the index if it was chunked, and finally we have the actual embedding, which is the list of vector. And yeah. Okay, so now that we are familiar with the type used throughout RAG or embedding pipelines, let's move on to the chunking piece. So in the chunking namespace, we defined an interface for implementing chunking strategies. So here the user defines the transform that splits the original document into sub-documents, or possibly for images into smaller pieces. It consumes an unstructured dictionary, and it outputs a collection of chunks. So the concrete implementation of this so far makes use of LangChain's chunking text splitters. So here's a pipeline snippet of how you can use it. So let's say the input is a document where content contains two sentences. There's some metadata like the source of the file, the language. Now we import the LangChain text splitter we want to use here, recursive characters text splitter. We configure it. We say the chunk size should not exceed 50. And let's split on periods. We also specify the field in the document that we want to consider as the content to be chunked, and the metadata fields we want to maintain. And you can also specify an ID function to assign your chunk an ID. So the output of this transform is the original document split into two chunks, each one sentence, along with the metadata we specified. Okay, so the next piece of the module is embeddings. This is a namespace for all the embedding model handlers that process chunks, and they output chunks with the embedding attribute set. So currently we support Hugging Face sentence transformers. So these are local models running on your VM, and then remote Vertex AI embedding models, which call out to the Vertex AI API. So here's an example of using Hugging Face text embeddings. Our input is chunks, and as you see, the embeddings have not yet been generated. We configure our Hugging Face model with a simple small model. We chain it in our ML transform, and the output is our original chunks. And as you can see, the embeddings are now generated. The next piece, now that we have generated embeddings, we need a way to ingest it. So the ingestion namespace defines an interface for implementing the transform to write to any vector database. So the only requirement is they process chunks, and the result of this transform is your chunks along with embeddings are written to a vector database. Okay, so here's an example of a concrete implementation for BigQuery. So we have our chunks, they have embeddings, they have some metadata like the source file, the language, and here we import the BigQuery vector writer. We add some configurations, what table to write to, create the table if it doesn't exist, truncate data, and then optionally we can map our chunks to our database schema if it's not in the default schema that this transform assumes. All right, so as a result of this transform, you can see the BigQuery table has the embeddings and the metadata associated with those embeddings. Okay, now moving on to the next piece, we have our data in a vector database, but now we want to do vector search. So vector search in Apache Beam makes use of enrichment transform, which relies in turn on request response IO. And this is a transform that looks up data in a remote service, but also gives you unique features like throttling and retries. So to illustrate this, let's consider an example here of a product catalog, online product catalog with a couple of product IDs, their descriptions, prices, and the embedded description of this product. Now, let's say we want to create a semantic search pipeline. So a user who comes with a query, I'm looking for a powerful laptop for video editing, and some sort of structured filter like the price has to be less than or equal to 2,000. So here we construct such a pipeline. The first step is to read from our source. Here it's pub sub. We convert the input, which is just a dictionary, to a chunk, so we can actually embed the user's query, which will be necessary to do vector search on our database. The next step is to actually configure our enrichment handler. So here we can see BigQuery vector search parameters. This is telling enrichment how to query our vector database. So the table is the product catalog. The table that contains the embeddings, the column is just called embedding. The columns we want to retrieve is the price and description. We have a metadata filter, so we pre-filter the table, and let's only return the first most relevant result. So as a result of this pipeline, you might get something like this, where the result is contained in the metadata. The chunk content is still the user's original query, but the metadata contains the enriched data, so the actual product from the vector database. It's laptop 1, it's an ultralight laptop, and the price is less than 2,000. Okay, so let's do a quick recap of what a full ingestion pipeline looks like. We read from some source. We optionally perform chunking if the documents are too large to be embedded individually. We configure our embedding model. And then finally, we configure our vector database, right? Here, it's writing to Cloud SQL Postgres. And on the other side, in our retrieval pipeline, let's say we read prompts from pub/sub. Now we have to turn these into chunks so they can be embedded. Finally, we perform vector search on our vector database. And this is where the generation part happens. We take our enriched data, turn it into a prompt, and then we can use run inference with the LLM chat model handler to do some sort of agentic workflows. All right, so some use cases for this RAG package is obviously bulk embeddings, continuously updating embeddings for data that's changing, like an online store where descriptions change. This depends, the database you choose depends on your use case. So Postgres, for example, has conflict resolution where you can continuously update your data. And then we can use run inference and vector search to create AI agents. And then there are some more advanced techniques that can be used, for example, for chunking. You can have an LLM summarize your document. Instead of breaking it into chunks, you can use an LLM to add more context about the overall document that this chunk was pulled from. So when you provide it in your prompt to your LLM, it can give you a more informed answer. All right, so I'm definitely interested to hear any other use cases people have for vector search, RAG in Apache Beam, and if there's any feature requests or ways people want to extend this, please feel free to take a look. And there are a bunch of collabs examples to be found here at the link on the Apache Beam GitHub repo. All right.